Now, the next screen is our system screen. This is where you'll operate the system from. So on the screen, we have a little visualization of the steam path of the system, plus some additional RPM, kW indication. So we have our inlet pressure and temperature. We have our valve demand, not position, but what we want the valve to be. In addition to that, we have our exhaust pressure indication. So that's our steam side. On the other side, we have our RPM, how fast the unit is moving. We have an indication, again, to match up with our breaker position. Green means open, red would mean closed. Below the generator, we have an indication of our power output, in this case our kW. And in addition to that, we have our power factor, what the power factor of the unit is. Real quick, while we're here, what we'll do is we'll show you for a monitor point, you have the following available. You have your status, which is a little bar graph, little scalable bar graph, along with an indication of our set points. So in this case, you can see we have a red low and a red H. Those are our trips. The yellow are our alarms. You want to see what those set points are, and again, this is for all monitor points. We can go to the set point screen, and we can see that all protection is enabled along with the set points. We have a little trend screen. This is a real-time trend. If you close this window, the trend goes away. So to maintain this trend, you need to leave this window open. Last screen is a detail screen. Under the detail, we can see what the scale is, what the fail is, and what the raw number is for the sensor. And again, that applies to all monitor points as such. Now, real quick, underneath all pop-ups, you'll have a menu. So on the bottom, you'll have a little menu. There'll be a close button for all pop-ups, and then each pop-up might have additional screens or it might not. The green means that's the screen you're on. Gray means the screen is available. So like I showed you before, we're currently on the status. I can go to the set points. That'll be now highlighted in green. I can go back to status, and then I can close it. And that applies to all pop-up screens. Moving to the right-hand side, we have our main menu. So at the top, we have an indication of what the current control mode is. In this case, we can see that we're currently shut down. So that's in control. Below that, we have an indication of where the what the control station is. In this case, the main panel is the control station. If I wanted to change that, and we will review the local panel after this, we will go through that. But for right now, the control station can be selected as either main panel or turbine skid. When you select that, what changes operation is speed adjust and start stop. Those are the only things that can be selected for each side of the control parameter. So in this case, we're going to leave it on main panel, and we'll be able to adjust speed and start stopping from the main panel. If I select local panel, that operation will move to the local panel. Start. So the start menu allows you to look at the permissives to start. And again, if the permissive has a green circle, the permissive is met. No green circle, the permissive is not met. In this case, if I reset, we can see that I now have my system reset start permissive. These are a list of all the start permissives. If you have a question on a parameter, in this case inlet steam temperature, and why the parameter is not met, we can go to the detail screen, and we can see that inlet pressure needs to be greater than 165 pounds. And again, if you have a question on the permissive not being met, the detail screen should provide you the information necessary to understand why you have not met the permissive. Underneath the permissives, we have our control. You have two modes of operation on a startup. You have an auto start and you have a manual start. Auto, the system will ramp to idle speed, which is 500 RPM. Once idle speed has been met for 5 minutes, the system will then continue on to rated automatically. For manual, the system will ramp to idle speed and it'll wait there indefinitely until an operator takes action to change that speed set point. either by putting a different speed set point in or by having the unit go to rated. Then the last step, once you've selected your control, you'll then have the run button. Once you press the run button, the system will start, if all permissives are met. Stop. For stop, once you press the stop button, you bring up the controlled shutdown screen. A controlled shutdown will do two different things. If the breaker is open, the controlled shutdown will ramp the speed set point to 0. Once the speed set point achieves 0 RPM, it'll then trip the unit. That is when the breaker is open. If the breaker is closed, red, then when you enable the controlled stop, controlled shutdown, it'll ramp the valve closed, your control valve, at a designated rate. Once you have achieved less than 50 kW and your valve is less than unload, then you'll issue a breaker open command. Once the breaker opens, goes from red to green, at that point we'll be back into the speed set point ramp rate. Again, you can cancel this shutdown at any time. If you cancel it while the breaker is closed, the system will immediately go back into normal operation and try and maintain either pressure or kW based on what you've got for a set point. If the breaker is open, the speed set point will stop at whatever it is and it'll stay there until you as an operator change that speed set point, either by going to idle rated or putting a different number in. Next, we have our control loops. Currently, this system is designed to have speed, exhaust pressure, and kW as controlled the governor valve. With the breaker open, speed will control the governor valve. With the breaker closed, red, exhaust pressure and kW will control the governor valve. Now, here you have an indication of actual value, which is the green. That's the actual PV, and the orange is your target. So in this case, we can see that for kW, our actual value is 0, and our target is 150. This is the same for all three loops. Now, under all three loops, they are identical with the following. For control, you have a status of the control loop itself. In this case, we can see that our control loop is in auto. If the control loop is in manual or override, then you'll also have an alarm to let you know why that is. Once you've cleared that alarm, we can reset the loop back to auto. Now, for set point adjustment, we have two methods. One method is to use the pink box. To do that, we press the pink box, we bring up the numeric entry, we put a new number in, we then hit confirm, we then ramp to that new number. So if you have the ability to adjust it using your push buttons. So in this case, I can raise it or I can lower it. That is the control. This is identical for all three loops. Tune, this is where we tune the control loop. Identical for all three loops. Config, this is where you can look at what the configuration is for that control loop. In this case, for exhaust pressure and kW, we have a min-max on our set point entry. You cannot put a number in greater than or lower than whatever the min-max are. And then we have our ramp rates. So we have a ramp rate for the entry and we have a ramp rate for the push button. Just a quick note, these numbers can be adjusted. To do so, you'd have to log in as admin. That will be provided to whoever the management decides. So that is the identicalness of all three control loops. So speed has a little bit of a difference. So under speed, under control, we have predefined idle and rated for you. Idle being 500, rated being 1800. By pressing this button, either one, you put that number in automatically. So you don't have to change the set point yourself. It does it for you. Config is a little different because we have a speed ramp where we have to do different RPMs at different points. This is where you can go to see the different idle times, rated times, and such and such. Last thing is test. So under speed, we have a test function. We have a peak. In this case, you can see that the last time we had the last peak speed we had was 1958 RPM. You can reset that. So every time you do a test, you can use this peak to record what your peak speed was on the test. We have two tests. One test is to eject a frequency signal into the local electronic overspeed. By pressing the test button, we inject that signal. We have a 1959 RPM injected. That causes a trip. If we go here, that trip is now clear, so we can go and look at our alarm history. And we can see that when I press that button, we received the electronic overspeed trip. The next test is an actual overspeed. So to perform that overspeed, you can, once you get to your permissive, start is active and at rated speed, you can press the start button. That start button will change your target to 1950. It'll then ramp itself to 1,950 RPM, at which point the local panel overspeed device should trip. If it does not trip, you can cancel that overspeed and then determine the failure. So again, start, it'll perform the test automatically. Stop cancels the test and the speed goes back to rated. Control loops. Again, we've already gone over the control station. Auto sync. Once you're at rated speed and the generator's excited, you can then enable your synchronization. To do that, we can come to this screen, verify our permissives, breaker is open, and the synchronizer is okay. If both those things are true, then we can synchronize. To synchronize, we'll either select auto or manual. If you select auto, this device and this device will adjust frequency and voltage to accommodate your necessary generator voltage slightly higher, generator frequency slightly higher. Once that is done, your sync scope will be slowly moving in this direction and it'll issue a close once it reaches the middle. In addition to this, your generator protection relay will be monitoring and also agreeing. So both these devices have to agree you're in phase and in the proper sequence for your breaker to close. So once your synchronizer and your protection relay agree, your breaker will close. If we select manual, at that point, you as the operator will be responsible for adjusting your voltage and your frequency to get to where you need to be. And again, our frequency can be adjusted by adjusting our speed set point. 1800 RPM is going to be 60 Hertz. Our voltage can be adjusted by moving to the voltage AVR button and then adjusting your voltage through these two raise lower functionality on the voltage regulator. So in manual, you've adjusted your voltage and frequency properly. Our sync scope is going slowly in the fast direction, and then you can hold this button. Once you're holding this button and this device agree, the breaker will close. This button does not close the breaker. This button just approves the synchronizer and the sync check to close the breaker. So again, you do not have to wait to press the button. You can hold the button. Once you're in phase, it'll close. Synchronizing. Next button is voltage regulator. Again, the only reason to be in the voltage regulator screen is to adjust your voltage through the use of these two buttons. Other than that, no need for the operator to use this screen. Last screen on our system page is our steam valve control. So again, we have a governor valve that's allowing steam into the system. That valve is controlled through this sequence. So when we're shut down, tripped, we're putting 0% in. Once we reset and start, the speed indicator will go green and it'll start to change to try and achieve rated idle speed, whatever the speed set point is. Again, speed is in control when the breaker is open. When the breaker is closed, exhaust pressure and kW will be green and they will be in control of the valve. And again, they do that by looking at their set points versus their actual process values and manipulating their outputs to try and get to set point. Again, low signal. So whatever the lowest signal is on the bus will control the valve. So in this case, if exhaust pressure is 4.26 and kW is 0.29, KW will control that valve. In addition to that, we have a valve limiter, which once the system starts, the valve limiter is always on the bus. The valve limiter can be used to lower the valve output in case of any type of troubleshooting or diagnostic activity. Other than that, there's no need to use the valve limiter for any reason. Last menu selection is stroke. The stroke would be for diagnostic and troubleshooting, not operator. So again, if necessary, that can be provided to the mechanic or electrical team to do diagnostics in the future. That is our system overview. Next screen, monitor. Under the monitor screen, we can do a quick look at our temperatures on the bearings for the turbine and the generator. We can also look at vibration on the generator. We can look at vibration on the gearbox, and then we can look at our stator. You have a cooler, a water cooler on the generator. You can see your air temperature in and your air temperature out. That's circulating through the generator. And then we have our stator temperatures. Our stator is embedded in the generator to determine how much heat is inside the generator. Next screen, lube oil. Under the lube oil screen, we have 1, 2, 3 pumps. We have a fan for, in this case, a little motor drawing air. We have a level switch, and then we have a temperature control. So, the main shaft pump is driven by the shaft. We have no control of that pump. That pump is purely speed driven. So as we get up in speed, that pump produces more and more oil. The ox oil pump you have control of by selecting ox oil. So we have off and auto. On the side, we can see an off permissive and an auto start. So if we want to turn it off, we can by pressing the off button if the permissive is met. If auto start is active, when I put it back into auto, the pump will start. To see additional detail on that, we can go to the detail screen. So we can see that off permissive requires post lube. Green is met, so we know that we can turn the pump off. Auto start is currently green, which is telling us that we're below speed. Once we get above speed in the auto stop, this light will come on, this light will go off, and the pump will be turned on. In addition, if we ever get to a low oil pressure, this pump will auto start immediately. If this pump comes on due to low oil pressure, you will have an alarm, and to secure it, you will have to meet the oil pressure, go back to control and hit the stop button. That will turn the pump off if it came on due to a low oil pressure alarm. Oil mist fan. This is the oil mist fan. There's a little canister with a fan above it that's drawing air out of the oil system through the canister. So this pump will always run if the ox oil pump or any oil system is operational. So as long as the system is in auto, the pump will run when necessary. The fan will run when necessary. Again, you can turn it off at any time, and you can see that if you turn it off and it needs to be running, you'll have an alarm. Oil mist separator not in auto. Lube oil cooling. Lube oil cooling will maintain your lube oil temperature at whatever your set point is, in this case, 113 degrees. Post lube. Post lube, once the system shuts down, we start a 5-minute timer. Once that timer has expired, we allow you to turn off the oil system. You cannot secure the oil system once it has been started until 5 minutes after shutdown. Emergency oil pump. If for whatever reason while you're running, you get a low oil pressure alarm, the emergency oil pump will come on for 5 minutes. Once the 5 minutes has expired, the oil system will secure itself, or the emergency oil pump will turn off. You have auto, off, and manual. If you are in anything but auto, you will get an alarm. If the emergency oil pump is off, you will get an alarm. If the emergency oil pump is in manual, you will get an alarm. Your oil pump needs to be in auto at all times to provide protection against the loss of oil pressure to your bearings. Oil system. Last screen, maintenance. Maintenance allows you to look at all your configurations on the system. And again, you have a sub-menu, speed sensor, exhaust pressure, kW, and so forth. This allows you to immediately see how the system is configured. You have an event screen. Under the event screen, this is an HMI event screen, which is only useful for diagnostics and troubleshooting for a qualified control instrument tech, not necessary for an operator. This button should never be pressed. If this closed runtime is pressed, the runtime will be secured. Once the runtime is secured, you are left with this screen. Immediately press Run Application. That'll bring your application back up. All right, we've gone over the the main control panel. Next step we'll review is the local control panel.